Okay, let's dig into this. When you think about economics, those really core ideas, scarcity, opportunity cost, supply and demand, they feel so solid, don't they? Almost like laws of nature for how economies work. But what if? What if that foundation isn't quite as permanent as we think?
Hmm. It's a really mind-bending question, and it's exactly what we've been looking at in the source materials for this deep dive. We've gone through various articles, research papers, getting perspectives from places like Google Cloud, IBM, and also digging into the science behind machine learning itself.
Right. And our goal here, our mission is really to pull out the key insights from all that material to try and understand this potential future where artificial intelligence, especially if you look at it through this idea of exponentially growing knowledge, how it might actually reshape those really fundamental economic pillars.
Exactly. The sources really highlight three principles as being sort of the bedrock. First, there's the principle of scarcity. I mean, it's pretty straightforward. Resources like time, money, materials, they're limited. But human wants, they seem, well, unlimited. So that forces choices. We have to allocate.
Yeah, and that allocation, those choices, they lead straight into the next one,
Yeah.
opportunity cost. Every time you choose one thing, you're inherently not choosing something else. Opportunity cost is basically the value, the benefit of whatever best alternative you gave up.
Precisely. And the third one is that classic law of supply and demand. That interaction between sellers, what they offer, and buyers, what they want, and how that whole dance determines prices and how much stuff gets made and sold. Now, the sources acknowledge other principles exist, of course, incentives, trade, efficiency, but they really zero in on these three as the most critical for this particular discussion about AI's potential impact.
Okay, so that's our bedrock. Scarcity, opportunity cost, supply and demand. Established. Now, to really grasp how AI could shake this up, we need to talk about something else the sources emphasize. This idea that knowledge doesn't just grow steadily, it accelerates, it grows exponentially. The curve gets steeper.
Right. And the sources use a fantastic example to illustrate this: the evolution of maritime technology. Ships. Think about it. From the very beginning, maybe the first century AD, up to around the 17th century, that's what, 1600 years? And what changed? You had oars, then sails, maybe some gradual tweaks to hull design, rigging. But fundamentally, progress was incredibly slow, almost glacial.
Yeah, you can imagine why, right? Knowledge spread was limited, you had local expertise, maybe some trial and error over generations, but very slow communication.
Exactly. But then, look at the next chunk of time, say 17th century to the early 20th, just 300 years or so, suddenly, bang, steam power. Robert Fulton's Claremont, things like that, no longer tied to the wind. Voyages get faster, more reliable. Then you get steel hulls instead of wood, propellers instead of paddles. The Industrial Revolution pours in better tools, mass production techniques, stronger materials like iron and steel, and shipbuilding starts using actual scientific principles more deliberately. Hydrodynamics, things like that. The pace just picks up dramatically.
And then the last stretch, maybe the last 120 years, 20th century onwards, it's just an explosion. Diesel engines, massive cargo ships, submarines, aircraft carriers, incredibly specialized vessels too, like autonomous ships, super yachts, even solar-powered ones. Plus, think about navigation, GPS, radar, sophisticated comms, and how they're built. Computer-aided design, AI, and logistics, new materials like composites and carbon fiber. It's completely transformed.
And the sources point to a few key reasons why it accelerates like this. One is the compounding nature of knowledge. Steam power built the foundation for diesel, which built the foundation for, potentially electric or other future propulsion. Each step enables the next.
Makes sense.
Then there's increased global interaction, trade, communication. Ideas spread faster. This sparks both competition and collaboration, pushing things forward.
Okay.
And technological synergy. Advances in seemingly unrelated fields like computing or material science suddenly become crucial for shipbuilding or navigation.
So the takeaway from the boats example is that things we think of as stable, foundational, they can change really, really fast once that knowledge curve takes off.
Precisely. And now the sources suggest that AI development might be on an even steeper part of that exponential curve.
Which brings us to how the sources categorize the potential stages of AI development. These are hypotheticals, right? But important for thinking about the scale of change.
Yes, very much hypothetical stages. The first one they talk about is artificial general intelligence, or AGI. This is the idea of an AI that isn't just good at one specific thing like playing Go or identifying images, but has broad, human-like cognitive abilities. It can understand, learn, and apply intelligence across basically any intellectual task a human can do. It's about versatility, like the human brain.
Okay, so like human intelligence, but in a machine. What's next?
Next up is artificial superintelligence, or ASI. And this is where things get, well, significantly more advanced. ASI isn't just matching human intelligence, it's surpassing it dramatically. Think cognitive functions, problem solving, creativity, processing speed, all far beyond the best human minds. It's a truly profound jump in capability.
Wow, okay. And is there anything beyond ASI in these models?
There is, though it's the most speculative stage, artificial universal intelligence, or AUI. This is described almost as a post-ASI era. It's where superintelligence isn't just static. It's continuously evolving, self-improving, and it becomes so pervasive and powerful that it fundamentally reshapes, well, everything, society, technology, maybe even our understanding of reality itself. Economics, governance, biology, consciousness, it touches all aspects of existence.
Right. That's definitely out there, conceptual.
Highly speculative, as the sources emphasize.
So if we tie that accelerating knowledge curve, potentially even faster than the ship's example, to this path towards maybe AGI and then possibly ASI, that's where the economic stuff starts to look really, really different, potentially very quickly.
Exactly. The sources suggest that an ASI, in particular, could have a truly transformative impact on those core economic principles we started with.
Okay, let's break that down. How might ASI affect scarcity? That seems like the most fundamental one.
Well, this is where it gets fascinating. The suggestion isn't just that ASI could help us manage scarce resources better, which current AI already helps with to some extent. The idea is that ASI might be able to find completely novel solutions that fundamentally alter what we even consider scarce. Imagine an ASI designing new, incredibly efficient materials from elements that are super abundant, or optimizing global resource extraction, use, and recycling with near-perfect efficiency. It could potentially redefine scarcity itself. Maybe certain limits just dissolve.
Whoa, okay, that really would turn economics on its head. So what about opportunity costs then, if ASI changes scarcity?
Opportunity costs could also be transformed. Think about making a choice. Right now, we weigh the pros and cons based on limited information and processing power. An ASI could potentially analyze virtually all possible options, all data points, all potential future consequences, and calculate the cost of foregone alternatives with superhuman speed and precision.
So decisions become perfectly optimized.
Potentially, yes. For individuals, for companies, for entire economies. It could optimize supply chains, R&D investments, resource allocation on a scale, and with an efficiency we can't even imagine. The whole feeling of a trade-off, the cost of choosing, might change dramatically if the optimal path becomes overwhelmingly clear.
Okay, that's huge. And the last one, supply and demand, that fundamental market force.
The sources suggest that, too, could evolve in really unprecedented ways. Imagine an ASI managing production and distribution globally. It could potentially predict consumer demand with near-perfect accuracy. It could adjust supply chains in real time, optimize logistics instantly, maybe even control automated factories to ramp production up or down precisely when needed.
So less fluctuation, maybe prices stabilize or behave differently.
Exactly. That level of efficiency and predictive power could dramatically alter how markets reach equilibrium. Traditional price signals based on shifting scarcity and demand might function completely differently, or perhaps become less relevant in some areas. The dynamics could be unrecognizable by today's models.
And stepping back, the sources even hint that if we ever reached that AUI stage, our current economic theories might just become obsolete, like trying to apply Newtonian physics inside a black hole or something.
It's a powerful analogy. But, and this is crucial, the sources are very careful to state this, we need to acknowledge the unknowns here. These are possibilities grounded in theory and projections, yes. But whether AUI is even achievable, or the exact timeline for ASI if it is,
Yeah.
that's all highly uncertain.
Absolutely. This isn't a prediction, right? It's exploring potential trajectories based on the material we looked at. And the sources definitely point out things that could change this whole picture.
Definitely. There could be major technological hurdles we just can't overcome, or we could take far longer than expected. There are enormous ethical questions, huge ones. How do we control something potentially vastly more intelligent than us? Who benefits? How do we prevent misuse?
Yeah, the ethical side is massive.
And then there are societal choices. How do we as a global society decide to develop this technology? How do we regulate it? How do we adapt our institutions, our education, our job markets? These choices will matter immensely.
So wrapping this up, this deep dive shows a plausible pathway based on exponential trends and AI potential. where our most fundamental economic ideas, scarcity, opportunity cost, supply and demand, could face radical transformation, maybe even obsolescence.
That's the core possibility presented in the sources. But it comes with huge caveats about uncertainty, technological limits, ethics, and critically, the human choices we make along the way.
It's a powerful parallel to that maritime example, isn't it? How quickly things change then, driven by knowledge. But AI seems poised for an even faster, potentially more profound shift.
It certainly seems that way, based on current trends and the analyses we reviewed.
So, something for you, the listener, to really think about. Which of those three core principles, scarcity, opportunity cost, or supply and demand, do you think is actually the most susceptible to being fundamentally changed by advanced AI? And maybe more importantly, how much influence do you think our societal choices, those ethical guidelines and regulations the sources mention, will truly have in shaping what that economic future actually looks like in an age of AI?